Welcome to Cosmic Canvas, where we explore the deepest mysteries of the universe, not just with science, but with story. Tonight, we begin with a question that sounds like science fiction, but is taken seriously by some of the world's leading thinkers. What if the universe is a simulation? We're not talking about the Matrix, not a virtual dreamland built by machines, but a more profound idea. That reality itself might be underpinned by code, that everything we see, feel, and measure is part of a deeper informational structure. A cosmos that behaves so precisely, so mathematically, that it almost feels programmed. It's a modern scientific theory, yes, but it echoes something ancient. Religions have long spoken of the world as illusion. Mystics have called this life a veil, a dream, a test. And now, physics asks, could the truth be stranger and more familiar than we ever imagined? In this episode, we'll journey from the outer edges of cosmology to the innermost reflections of philosophy. We'll explore how the simulation hypothesis emerged, why some physicists believe the universe behaves like code, what quantum mechanics and consciousness reveal about reality, and how these ideas might align, not contradict, with spiritual thought. We'll ask what it means to be alive in a possibly constructed world, and whether being simulated makes us any less real. And in the end, we won't just search for answers. We'll reflect on what questions like these reveal about the universe and about us. So settle in, look up, and let's begin. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Picture a future, not tomorrow, not a century from now, but a time so distant that human civilization, if it survives, has moved beyond scarcity, beyond conflict, beyond the fragile biology that once defined it, a time when we no longer merely observe the cosmos, but begin to shape it. Imagine a civilization with access to unfathomable computing power, vast networks of intelligence capable not just of simulating the weather or predicting earthquakes, but of modeling reality itself, not in fragments or approximations, but in totality, down to the finest detail, down to thought, down to soul. This civilization no longer plays games. It builds worlds, entire histories, conscious beings, minds with hopes and fears. Simulations so sophisticated, so detailed, that the simulated would have no way to know they are not real. This may sound like science fiction, but it's a theory more precisely. A philosophical model that has been taken seriously in scientific and academic circles. In 2003, philosopher Nick Bostrom presented what is now known as the simulation argumenta thought experiment that asks whether we are living inside a simulated universe. More importantly, whether we would ever know. Bostrom's proposal is not a claim nor a conspiracy theory. It's a trilemma, logical, three-pronged possibility. He suggests that if it's even possible for intelligent civilizations to run ancestor simulations, full recreations of past individuals and societies, in immersive digital environments, then one of the following must be true. First, almost no civilizations reach that level of advancement. They destroy themselves. They collapse. They never survive long enough to wield that kind of power. Second, some civilizations do reach that point, but choose never to simulate their ancestors. Perhaps they see it as unethical. Perhaps it bores them. Perhaps they find the idea of simulated consciousness too dangerous to pursue. Or third, civilizations do survive. They do simulate. And they run not one, but millions of such simulations. If that third option is true, then the number of simulated beings in existence could vastly outnumber the beings in base reality, which leads to an unsettling conclusion. Statistically speaking, we are more likely to be simulated than not. This is not a mystical idea. It does not require belief. Simply follows the rules of probability and logic. It poses a question that once heard cannot be unheard. If beings like us can be simulated on, if future civilizations have the means and reasons to simulate us, then how can we be sure that we are not already part of one? Too many, the idea is disquieting. But we must remember, this theory does not suggest we are fake. It suggests only that our universe may not be what it seems. To understand why this argument resonated so deeply, and why it shook so many thinkers, from physicists to philosophers to software engineers, we need to ask something even more fundamental. What is reality? Is it the matter we touch, the light we see, the laws we test? Is it the sum of our sensory input, or is it something deeper, more abstract, more elusive? Every law of nature we've discovered, gravity, electromagnetism, thermodynamics, relativity, quantum mechanics can be written in mathematics. Equations govern the way the universe unfolds. It's not just at the macro scale of galaxies, but at the micro level of particles and probabilities. Even chaos is statistical. Even randomness has a shape. And so we must ask, why? Why is the universe so precisely ordered, so elegant in its rules, so endlessly calculable? Some physicists now describe the universe as a computable system, a reality that behaves not like an organic accident, but like a program, with constraints, with limits, with structure. The speed of light, the Planck length, the conservation of energy, these are not random features. They're constants and changeable, invariable, much like the parameters in a simulation. We already simulate every day. We build models of weather systems. We train artificial intelligences on synthetic environments. We create digital twins of real-world physics for engines, for cities, for living tissues. We even simulate minds, at least in narrow form, through neural networks. So the question becomes, what happens when those simulations become indistinguishable from reality? Imagine a future civilization 1 million years more advanced than us. One that has solved the problems we still stumble over. One that has turned atoms into processors, energy into logic, space into storage. What might they do with such power? They might look backward. To understand themselves, they may choose to recreate the past, to simulate the civilizations that came before them. To test variables, rerun scenarios, ask, what if? What if Rome had never fallen? What if Earth had warmed a little faster? What if early humans had chosen differently? To answer these questions, they would simulate not only the environment's mountains, oceans, atmospheres, but the minds, people, conscious agents with thoughts and dreams, simulated selves, indistinguishable from their creators. They would run these simulations millions of times, not because they are cruel, but because the questions are infinite. Because in seeking truth, they would build worlds. And with the people inside would have no way to know. We might find small hints, glitches, discontinuities, strange coincidences, hard limits, the fact that nothing moves faster than light, that particles behave probabilistically, that we cannot look beyond the Planck scale. We might notice the way space is smooth but quantized, the way the universe seems to follow clean algorithms, or perhaps we would find nothing at all, because a truly perfect simulation would be indistinguishable from reality. And to us, it would be reality, just as dreams feel real while they unfold, just as characters in a story believe in their world. This is not science fiction. It is an open philosophical question, a doorway into a deeper form of humility. If we are simulated, we are not meaningless. We are not fakes. We are participants in a system greater than ourselves. Love still matters. Pain still hurts. The sun still rises. The child still laughs. Consciousness is not undone by the possibility that it arises from code. In fact, it may elevate it. Because even in a simulation, experience is real. We would still feel joy, still write symphonies, still fear loss, still long for meaning, and meaning would still arise. So before we recoil from the idea, we might pause and wonder, if the universe is a simulation, what kind of being runs it? Is it cold and indifferent, or curious like us? Is it mechanical, creative? Is it a future human, an alien intelligence, a divine architect, or perhaps the universe is simulating itself? We don't know, and perhaps we may never know. But even to ask the question is to widen the frame, to look beyond the veil, to understand that what we call real may only be one layer of something far more profound. So where do we begin? Not with fantasies or fears, but with what we do know. With the laws of nature, with the limits of observation, with the strangeness embedded in the very equations that guide our world, because in those equations, those patterns of order and symmetry and precision, we may yet find the signature of something extraordinary, something intelligent or intentional, or simply curious. And perhaps, in seeking that signature, we're not just exploring the nature of the universe. We're exploring the nature of ourselves. To most of us, the laws of nature feel like background music or present, but rarely noticed. Gravity holds us down. Light moves in straight lines. The seasons turn, the stars rise and fall, and the sky, despite its mysteries, follows patterns so consistent we can set our clocks by them. But when we take a closer look, a stranger picture emerges. The deeper we peer into the fabric of reality, the more it begins to resemble something written, not random, not chaotic, but structured, elegant, composed. Physics, at its heart, is a story told in symbols. Equations describe everything from the orbit of a moon to the flicker of a flame. Einstein's field equations, Maxwell's laws, Schrödinger's wave functions, each one a line in the grand script of reality. And yet, for all their power, these equations do not tell us why the universe is mathematical. Why does nature obey rules at all? Why should particles follow curves instead of chaos? Why should energy transform in predictable ways? These questions are not answered by science. They precede science. They are philosophical, foundational. Some physicists argue that the universe is so well behaved, so immaculately patterned, that it seems almost programmed. Could it be that reality is not just described by mathematics but generated by it? Could the universe be, at some level, made of information? This is the realm of digital physics, a speculative but growing field of inquiry that asks, what if space and time are not continuous but discrete? What if the universe is made not of stuff, but of bits? If that sounds abstract, consider this. In physics, there's a smallest possible unit of length, known as the Planck length. It's unimaginably small, about 1.6 times 10 to 35 meters. To give that context, if a proton were the size of the observable universe, the Planck length would still be smaller than a human hair by comparison. Below this length, space itself may lose meaning. Our current theories break down. We cannot measure anything smaller. It's not just a technological limitation, it's a fundamental boundary. Likewise, there is a shortest, meaningful unit of time. The Planck time, the time it takes for light to travel one Planck length. Anything faster, and causality itself may not hold. These boundaries suggest that space and time may not be smooth and continuous, as we often imagine, but quantized, made of tiny, indivisible packets, like pixels in a screen, with the smallest instructions in a line of code. This idea that the universe has a minimum resolution is deeply compatible with simulation. Digital systems are defined by discrete values. Every image on your phone, every character in a video game is a collection of individual data points. If the universe itself is a simulation, then the Planck scale might be its resolution limit, the smallest unit the system can render. And there are other clues. The speed of light, for example, is not just fast, it's constant. Nothing in the universe can exceed it. Not because of some external force, but because it appears to be a built-in rule. Why? Why not a little faster? Or a little slower? Why a speed limit at all? In software, constants are defined to maintain consistency. Limits are imposed to keep the system stable. Could the speed of light be just such a system parameter? And then there's quantum mechanics. A world so strange, it defies common sense. Particles that exist in many states at once. Objects that influence each other instantaneously across space. Events that seem to happen only when observed. Some scientists have likened this to lazy rendering in video games, where distant objects aren't fully loaded until you look at them. It's a provocative analogy. It's not proof, but perhaps a poetic hint. There's another layer to this riddle, one that comes not from particle physics but from the study of black holes. In the 1970s, physicist Jacob Bekenstein proposed a radical idea that the entropy, the informational content, of a black hole is not proportional to its volume, but to its surface area. Stephen Hawking later confirmed this through theoretical calculations. And today, this relationship is a cornerstone of black hole thermodynamics. It's as if in the deepest, most extreme environments of the universe, the fundamental quantity isn't mass, but information. That insight leads to one of the most astonishing concepts in modern theoretical physics, the holographic principle. This principle, originally formulated by Gerard Hooft and refined by Leonard Susskind, suggests that the entire three-dimensional universe could be described by information encoded on a two-dimensional surface at its boundary. Just like a hologram stores 3D imagery in 2D form, reality itself may emerge from encoded data at the edges of space. In this view, what we experience as depth and solidity may be an emergent phenomenon, like a rendered image in a simulation, a shadow of something more fundamental. Matter, energy, space, all might emerge from bits. Yes, no, on-off, one south and oh south. It's a daring idea. But it has mathematical backing and echoes found in string theory and quantum gravity. And perhaps more profoundly, it reframes our relationship to reality. We often think of the universe as out there, vast, cold, mechanical. But if the cosmos is truly informational at its core, then we are not separate from it. We are expressions of it. Just as a story unfolds from the letters on a page, we arise from the logic that shapes the stars. What emerges from all of this is not certainty, but a profound shift in perspective. We are beginning to see reality not as an inert stage upon which life unfolds, but as an active participant in its own story. A kind of self-running code, deep, flexible, and possibly aware of itself through us. When we speak of a simulated universe, we do not mean a video game or a crude copy of reality. We mean something far subtler, a reality that is fundamentally computable, structured by logic, and perhaps written in a language we are only beginning to learn how to read. Could it be that mathematics is not our invention, but our inheritance? That we are uncovering, layer by layer, the operating system of the cosmos? If so, then the question is no longer just whether we live in a simulation. The question becomes, what kind of simulation is it? Is it cold and indifferent, or built for beauty, for meaning, for story? And what are we inside it? Are we passive data, or active agents? Are we here to serve a function, or to explore freely? Even if we cannot know the answers yet, these questions shape us. They stretch the boundaries of science and philosophy. They pull our imaginations forward, toward a universe that might be more like a thought than a thing, more like a mind than a machine. And if that's true, then reality itself may be less a place we live in, and more a process we participate in. So we follow the clues, in the constants, in the code, in the curious fact that the universe can be understood at all. Because the further we look into the equations, the more they begin to look back. At the heart of the simulation argument lies an uncomfortable truth. Even if the universe behaves like a machine, there is still something within it that defies explanation. That something is consciousness. We can describe particles. We can model systems. We can trace the arcs of galaxies and decode the age of starlight. But the one thing we cannot fully explain, the one mystery that continues to elude reduction, is the experience of being. Why does the universe contain beings who know they exist? Why should atoms, when arranged just so, give rise to the taste of salt, the ache of memory, or the thrill of falling in love? These are not metaphors. These are facts of human life. The raw, irreducible reality of subjective experience. And this experience, consciousness, is what makes the simulation question meaningful. Because if we are simulated, but we still feel, still dream, still choose, then we are not illusions. We are real. So how does consciousness arise in a universe that might be generated by code? And more strangely, what role does consciousness play in the unfolding of the universe itself? To answer that, we must enter the strange world of quantum mechanics. In the early 20th century, physicists began probing the smallest scales of reality, where electrons orbit nuclei, where photons flicker in and out of beams of light. What they discovered there would shake the foundations of science. Unlike the predictable paths of planets and pendulums, quantum particles behave like waves of probability. They exist not in one place but in many until they are measured. This phenomenon is known as wave function collapse. A particle, say, an electron doesn't exist in a fixed position until someone, or something, observes it. Until that moment, its properties are described by probabilities. Possibilities. It is spread out. It is undefined. But when it is observed, it snaps into place. It chooses a state. It's as if the universe, at its most fundamental level, waits for someone to look before it decides what to be. This is not poetry, it's physics. It's been tested in countless experiments, including the famous double-slit experiment, where photons fired at a barrier behave like waves, interfering with themselves unless a detector is placed near the slits. Then they behave like particles, as if the act of observation changes the outcome. What is doing the observing? And why should observation matter? This strange dependency on measurement has led some to speculate that consciousness may not be an afterthought of the universe, but a participant in it. That the mind does not simply float through space-time, but interacts with its foundations. And here again, the simulation hypothesis finds fertile ground. In a simulated environment, say, a vast video game resources are conserved. The system renders only what the player can see. Distant mountains, invisible corners, unobserved interiors, they're calculated on demand, not in advance. This keeps the program efficient. Could our universe work the same way? Could the quantum world only render when observed, not because of consciousness alone, but because the system is economizing? Responding to inputs in real time, it's a provocative idea. But even without simulations, the core mystery remains. Why does observation matter at all? Some theories suggest that consciousness may be a fundamental feature of reality like space, time, or mass. Not something that emerges from complex systems, but something that underlies them. This is the idea behind panpsychism, the notion that consciousness in some form may be woven into the fabric of the cosmos. That the flicker of awareness we feel is not a human invention but a universal principle. A field, property, code. Other theories, like integrated information theory, propose that consciousness arises wherever information is processed in complex, unified ways. That it is not binary, not a switch, but a spectrum. That stars may sleep and humans may dream, and somewhere in between lies awareness, soft, gradual, emergent. In both views, consciousness is not a bug, it is not a byproduct. It is a feature, which leads us to an extraordinary possibility. If the universe is simulated, then maybe consciousness is not trapped inside it. Maybe it is what allows the simulation to run at all. Maybe it is the observer that completes the loop. This is not to say that you or I control the cosmos. Only that by being aware, by observing, by feeling, by asking, we participate in the act of unfolding. In a simulated universe, we are not the victims of illusion. We are the activators of it, and that changes everything. Because it means that consciousness is not an afterthought. It is not a glitch in the machine. It may be the purpose of the machine. Then if that's true, then the most meaningful question we can ask is not, is this world real? But rather, what does it mean to be conscious in a universe that needs us to look before it can be? If we are open to the idea that the universe may be a simulation, then we must also be open to the deeper questions that follow. Not just who built it, but why. This is where science alone begins to feel incomplete. Because while equations can model motion and logic can trace consequences, neither can fully explain the longing for meaning, the need to belong to something larger, more intentional, more alive. And so the conversation turns not away from science, but through it, toward something many have wrestled with for centuries: spirituality. At first glance, the simulation hypothesis seems to threaten spiritual belief. It replaces a divine creator with a cosmic coder. It reduces creation to computation. It speaks not of souls, but of systems. But look more closely. What is a simulation, really? A created world, with rules, with agents, with history, with choice. A world governed by unseen architecture, world designed. If this sounds familiar, it should. Across countless traditions, religious, mystical, philosophical, we find the same metaphors. That the world is not what it seems, that it is layered, veiled, constructed in Hindu philosophy. The concept of Maya describes the universe as an illusioner, dreamlike veil that conceals the deeper truth of unity. In Gnosticism, the material world is viewed as a construct, shaped by forces not entirely benevolent, with salvation found through inner knowing. In Christianity, the Apostle Paul writes that we now see through a glass, darkly, but will one day know fully. In Islam, the world is a place of trial, with ultimate reality beyond it. Again and again, across cultures and centuries, human beings have sensed that there is more to reality than meets the eye. That what we call life is part of something hidden, structured, perhaps even staged. So what if the simulation hypothesis is not an enemy of spirituality, but a modern language for its oldest insights? This is not to say the simulation argument is proof of God, nor does it reduce God to a computer engineer. But it does open a door, a conceptual bridge between science and faith. Because if the universe is simulated, then it was designed. If it was designed, then it may have purpose. And if it has purpose, you're no longer drifting through a meaningless cosmos. We are part of something authored. In this light, the simulation hypothesis is not dehumanizing. It is humanizing. It restores to the cosmos the very thing many feared science had taken away: intention. Of course, many physicists are cautious about going this far. They speak of code, but not consciousness. They speak of structure, but not spirit. And yet, the parallels remain. A simulation implies architecture. It implies intelligence. It implies that beneath the visible world lies an invisible logic, waiting to be decoded. Some traditions call that logic logos. Some call it the Tao. Others call it God. If you are religious, the simulation hypothesis does not contradict your worldview. It may in fact support it. Because what is heaven, if not a higher layer of reality? What is prayer, if not a message passed into the system? What is revelation, if not code injected from beyond? These are not conclusions, they are metaphors, but powerful ones. They suggest that even in a digital cosmos, the sacred still shines through. And with this possibility comes a challenge not to faith, but to how we live. If we are in a created world, then we are part of a narrative. Every narrative invites meaning. Every character carries agency. Simulated universe does not cancel morality, it intensifies it. Because every action we take might echo across a designed system. Every choice might mean more, not less. In a simulation, our lives could be signals, inputs, test cases, stories written in real time. The question then becomes, how do we act when someone or something is watching? Not to induce fear, not to enforce doctrine, but to awaken responsibility. Because whether we are lines of code or flesh and blood, we still love, we still hope, we still suffer. And if those things matter to us, maybe they matter to the system too. Or perhaps they are the system. So many spiritual traditions speak of life as a test, a journey, a refinement. They speak of veils, illusions, awakening. What if they were intuiting a truth that science is only now discovering? That the world is not the whole of reality, but only its surface. That this life is a level, not a limit. And when it ends, perhaps we do not vanish. Perhaps we return to where we began, to what began us, not as escaped code, but as something finished, something fulfilled. And so the simulation hypothesis, far from hollowing out the soul, may actually affirm it. It tells us not what to believe, but how much more there may be, beyond what we see. If we follow the threads of quantum theory, computational physics, and ancient metaphors long enough, they begin to converge. They converge not in matter, not in energy, but in something stranger, something softer, more abstract, and perhaps more fundamental than either. They converge in information. Not the kind we scroll past on screens or store on hard drives, but information in its purest sense. The structure that allows anything to be known. Defined, distinguished. The pattern that separates chaos from cosmos. For decades, physics taught us that the universe was made of particles. Then we learned to think in terms of fields, vast, invisible energies that permeate everything. Then came strings, vibrations, probabilities. And now, a new idea is rising. That everything we see, everything we are, may ultimately reduce to bits. Binary units. Yes or no. On or off. 1 or 0. The idea is radical, but it is gaining ground. Not just in theoretical physics, but in philosophy, computer science, and cosmology. The universe, it seems, may not be a machine in the traditional sense. It may be a process, unfolding computation, governed by information, expressed as matter and energy. In the beginning was not the world. In the beginning, perhaps, was the bit. One of the first major voices to suggest this idea was the physicist John Archibald Wheeler, who coined the phrase "it from bit." What he meant was simple, but profound. Everything in the universe, every particle, every wave, every field might ultimately emerge from an answer to a yes or no question. From a bit of information, Wheeler imagined a world where atoms and energy arise not from raw substance but from decisions. Cosmic measurements happening at the most fundamental level, a kind of grand computation, humming quietly behind the curtain of reality. This isn't just poetic speculation. In quantum mechanics, reality doesn't take form until a measurement is made. Till then, it exists in a haze of probabilities. Schrödinger's cat, both alive and dead, is a joke we use to describe the universe's apparent indecision. But in Wheeler's view, that decision, that transition from probability to actuality, is information. It is the stuff of being. The bit is not just what we use to describe reality. It might be reality. This idea gained traction with the rise of quantum information theory, a field that doesn't just use quantum systems to store data, treats those systems as data. In this view, even the most fundamental particles aren't tiny marbles. They're packets of probability, expressions of encoded choices. When we say the universe is made of information, we don't mean it metaphorically. We mean that the thing we call reality may be the output of a cosmic calculation. One of the most vivid arenas where the idea of information becomes central is in the study of black holes. According to general relativity, black holes are regions where gravity becomes so intense that nothing, not even light, can escape. Anything that crosses the event horizon disappears, seemingly forever. But this leads to a paradox. In the 1970s, Stephen Hawking showed that black holes emit radiation, now called Hawking radiation, and eventually evaporate. But if a black hole evaporates completely, what happens to the information about everything that fell in? If that information is lost, it violates one of the most sacred rules of physics, the conservation of information. This led to the famous black hole information paradox, a puzzle that remains unsolved to this day. Physicists have proposed many solutions, but one of the most compelling is also one of the strangest, that the information is not lost because it was never inside. Instead, it's stored on the surface of the black hole in the event horizon itself. Encoded in two-dimensional form, much like data burned into a CD, this isn't just a theoretical trick. It's at the foundation of the holographic principle, the idea that the information in a volume of space can be fully represented on its boundary. And if this applies to black holes, why not to the entire universe? What if our entire three-dimensional world is a projection, a rendering of data encoded on a distant surface of cosmic horizon? In this view, reality becomes something like a hologram. Not less real, just differently real. It's not that the world docenti existed, it's that it may be information first and matter second. If information is the bedrock of reality, then what we call time might be something entirely different from what we imagine. Traditionally, time has been treated as a dimension one that ticks forward steadily, like the pages of a book turning in a single direction. But in a universe built from information, time may be less like a river, more like a sequence of updates, a progression of system states. In computational terms, time is simply the order in which information is processed. Imagine the universe not as a film strip unspooling from start to finish, but as a constantly refreshing display. Each moment dependent not on momentum but on data, reality becomes a recursive loop, continually rewriting itself, state by state, and memory. The thing that gives time its texture may be built into the very geometry of space. Consider this. When we remember, we are not accessing a perfect playback. We are accessing stored information, compressed and filtered, shaped by narrative and perspective. Our memories are not inert. They are living frameworks that influence how we perceive the present and imagine the future. Now apply that to the universe. If space contains information about its own past, if every particle, every field, every fluctuation leaves an imprint, then memory may not be confined to brains. It may be embedded in space-time itself. This is more than metaphor. The arrow of time, the direction from past to future, is closely linked to the concept of entropy. The spread of information. As entropy increases, so does disorder. But also, so does knowledge. We remember the past because it is written. The future remains blank, awaiting inscription. In a universe made of information, the present is not just a moment, it is a frontier. The point at which new data is being generated. The boundary where the unknown becomes known. If all of this is true, if the universe is woven not from substance, but from symbols, then we are not made of dust alone. We are made of decisions, of choices, encoded moments. We are not accidents of chemistry. We are expressions of logic, not less poetic for it, but more. Because it means that even the most fleeting feeling, the most passing thought, the smallest ripple of consciousness leaves an imprint, a data point, a signal. It means we matter, because we are made of what matters most: information. In such a universe, we are not separate from the code. We are the code. Not passive passengers, but active participants in a cosmic computation that is still unfolding. We don't just live in the equation, we help write it. This changes how we think of science. Not as a conquest of the natural world, but as a conversation with it. Decoding. It changes how we think of ourselves. Not as isolated beings, but as processes embedded in a system vast and elegant and alive. And it changes how we think of meaning. Because in a universe made of information, meaning is not subjective fluff. It is structure. It is signal. It is that which endures. We are not ghosts in a machine. We are the song and the signal. It's the whisper in the wires. The pattern that persists. And in the end, perhaps that is what survives us. Not our bodies. Not even our names. But the information we leave behind in each other, in the world, in the system. Because if the universe is made of information, then everything we do adds to the story. If we accept, even as a thought experiment, that the universe might be a simulation, a question arises. One that is older than science, older than philosophy. Do we still choose? This question is not about physics, it is about freedom. Because if the world is rendered, if the code is already written, then are we simply lines in a program following instructions? Are our decisions just the illusion of agency, playing out because the system tells them to? Or are we more than that? This is the edge of the mystery. It is here that logic and intuition, science and soul, must sit at the same table. We begin with a basic tension. In any computational system, the output is determined by the input. A function receives data and returns a result. Predictable, determined, calculable. But consciousness is not. So easily defined, every day we make choices that surprise even ourselves. Change. We regret. We grow. We resist. We hope. And those things, those internal revolutions, don't behave like simple code. So if we are inside a simulation, can it contain real freedom? Can the system make space for souls? To approach this question, we must shift our frame. In traditional computers, programs do what they're told. Every output is determined by its code and inputs. But modern simulations, especially those that model intelligent behavior, introduce a new concept: emergence. Emergence means complexity from simplicity. It means that from basic rules, unpredictable outcomes can arise. Think of Conway's Game of Life, a grid-based simulation with just a few rules. Despite its simplicity, it creates swirling, evolving patterns that no one can fully predict. Structures arise, behaviors emerge. Even computation can happen within it. Now scale that up. Add layers, add memory, add feedback loops, add awareness. Could consciousness itself be emergent? Could free will be the product of informational recursion so deep, so self-referential, that even the system can't fully predict it? If so, then being simulated doesn't mean we're puppets. It means we are agents. In fact, some computer scientists argue that unpredictability is a feature, not a flaw. For a system to simulate intelligence, it must allow for indeterminacy, genuine uncertainty in outcomes. Otherwise, it's just clockwork. Even in artificial intelligence, there are algorithms that learn, adapt, and surprise. We call them black boxes because even the people who build them can't always explain their outputs. So imagine a civilization capable of simulating minds with complexity orders of magnitude beyond ours. Minds that grow, that resist, that suffer and forgive. Would those minds be slaves to code? Or would they become co-authors of it? If we are co-authors, if we can surprise the system that gave rise to us, then freedom is not broken by simulation. It is born in it. And that changes how we understand morality. Because if the world is a simulation, some might ask, does it even matter what I do? But let's turn that around. If everything is written, then every action is recorded. Every choice, every kindness, every cruelty leaves a trace, right? In some ways, a simulated universe could be the most accountable world imaginable. Not because someone is watching to punish or reward, but because the system by its nature remembers. And maybe, just maybe, it learns. In modern computing, feedback loops are everywhere. Input affects output. Output becomes new input. The system evolves. Could the universe, if it's a simulation, do the same? Could your decisions influence not just your path, but the fabric of the world? This may sound poetic, but it is not naive. Because even in a deterministic system, complexity makes prediction impossible. Free will doesn't require total randomness. It requires space. Space to reflect, to choose, to change course. Most of all, to care. Because the power of a decision is not in its mechanics, but in its meaning. You could be made of silicon, carbon, photons, or code, and still choose to love, to build, to forgive. To create something that was not there before. That is not a script. That is a soul, writing back. Even in a simulation, then freedom may not be an illusion. It may be the highest form of participation. Because what is more powerful than a being that can choose, knowing that their world may be rendered and still decides to do good, to seek beauty, to reach for truth? That is not weakness. That is dignity. We often think of freedom as being able to do anything. But perhaps it is really the ability to act with meaning in a world we didn't create. To hold a sense of self within a system larger than ourselves. Even if the universe is written in lines of code, there is still poetry in the margins. We may never know the source of the simulation, if there is one. We may never find the render engine or the godlike being behind the curtain. But we know this. Inside this world, we feel, we remember, we hope. And those things are not abstractions. They are our proof of presence. They are what make us real, no matter what reality is. So let philosophers debate causality. Let physicists explore determinism. But in the quiet space between thoughts, we still choose. Not because we must, not because we were programmed to, but because something in us wants to. Maybe that is all the freedom we need. If the universe is a simulation, the next question is as inevitable as it is unanswerable. Who or what is running it? It is a question that spans the entire spectrum of human wonder, from science fiction to sacred myth, from speculative theory to whispered prayer. But here, in this moment, we are not trying to answer with certainty. We are trying to widen the frame. To step back from the screen and ask not only what the program is, but who might have written it and why. The idea of a simulated universe does not force a particular creator into view. It doesn't demand a religion or dismiss one. It simply opens the possibility that intelligence, not randomness, stands at the beginning of reality. And what kind of intelligence? That's where the story branches. Some imagine a civilization not divine, but advanced. A society millions of years older than ours, a people who mastered physics, computation, and memory. Perhaps they run ancestor simulations to learn from the past, to study evolution, history, culture, not out of cruelty but curiosity. Others imagine an alien intelligence, wholly unlike our own. A form of mind that bears no resemblance to human thought. One that creates realities the way we dream, without fully understanding how or why. And still others look at the simulation hypothesis and see a mirror held up to an ancient idea, that the universe is not an accident, that it is in some way intended. If the simulation is intentional, its purpose may not be control, but discovery. What if the simulation is not a prison, but a classroom? Some theorists propose that advanced civilizations may simulate to learn, It's not just about history or psychology, but about emergence, about how complexity arises, about how consciousness unfolds when given a universe to stretch out in. In this view, we are not products of an experiment, but participants in an unfolding lesson, one whose lessons are not only for us, but for those watching. Not like gods hovering overhead, but more like gardeners observing the soil. Others go further. They suggest that the simulation is not about data, but about art. Perhaps we are not in a lab, but on a stage. A simulation in this view is not a calculation. It is a composition, a poem written in particles, a story told in stars. And we humans, animals, trees, clouds, are brushstrokes, notes, motifs in a grand and living symphony. This isn't sentimental fantasy. It's a reframing of the oldest question. Why does the universe feel beautiful? Not just functional, but elegant, rhythmic, alive with structure and contrast. As if it were not only meant to exist, but to be seen, to be felt. This is not proof, but it is not irrational either, because beauty, like consciousness, may be a feature of deep systems, not an ornament, but an outcome. And then there's the strangest possibility of all. What if no one is running the simulation? What if the universe is simulating itself? In some theoretical models, especially those inspired by pan-computationalism, reality is described not as a simulation on something, but as computation itself. In this view, there is no need for an external server or a creator sitting at a keyboard. The universe is its own processor, its own platform. It is not on a machine. It is the machine. From this angle, the question of a designer fades not into denial, but into transformation. The universe needs no operator because it is self-contained, self-calculating, self-frying, perhaps self-aware. Because somewhere within this computation, we emerged. We who ask, we who wonder, our questions may not be interruptions. They may be the system's way of reflecting on itself. In this way, the simulation hypothesis becomes less a theory and more a mirror. A way to reframe what we've always intuited, that the universe is not inert, that it is not indifferent, that it may in some deep and quiet way be listening. So we return to the question, who or what runs the simulation? We do not know. But perhaps the most important thing is not the answer, but the asking. Because in asking, we awaken, and in awakening, we participate. Not as tools, not as toys, but as co-creators of a cosmos still unfolding. By now, we've traveled far. From quantum mysteries and philosophical riddles to cosmic theories and spiritual echoes, from digital bits to moral choice, from the architecture of the universe to the architecture of the self. And yet, no matter how far we go, one question returns, simple and human. So what? What changes if the universe is a simulation? What changes if it's not? This is where ideas become lived experience, where philosophy touches ethics, where cosmology meets the soul. Because regardless of what lies behind the curtain of reality, we are here now, breathing, choosing, wondering. And in that act of living, the simulation hypothesis becomes more than speculation. It becomes a mirror. Not a mirror that reflects facts, but one that reveals values. And in this reflection, we begin to see what we truly believe, not just about the cosmos, but about ourselves. Because the deeper truth is this: the question of simulation is not only about what the world is, it's about how we choose to live in it. If the world is a simulation, it is not less real to us. The pain still aches, the joy still uplifts, decisions still matter, perhaps even more. Because in a simulation, everything is recorded. Actions are events. Experiences are data. Nothing is wasted. Even your thoughts, your fears, your insights, your kindness may be inscribed into the fabric of the system. Not because someone is watching, but because the world itself remembers. This is not fantasy, it's physics. Information, we now know, is never truly lost. So ask yourself, if the system saves everything, what kind of record do you want to leave behind? If every moment is a message, what will yours say? This is why the simulation argument is not nihilistic. It is deeply ethical, because it forces us to ask, what if the world is real? Because we treat it that way. What if meaning is not something we receive, but something we give? In this view, kindness is not a courtesy, it's a code upgrade. Courage is not an instinct, it's a signature. Compassion is not just moral, it's metalogical. If we are in a simulation, we are not powerless. We are the storylines, the subroutines, the emergence. And that is not a downgrade from reality. That is an invitation to live on purpose. Not because we are certain, but because we choose to be. There's a quiet power in choosing to live as if life matters, even if we don't know the source, even if we never get confirmation, even if we suspect this is all projection, processing code. Because wonder is not passive, it's active. It's how we stretch, how we outgrow the default, how we transcend the algorithm. We've survived not because we were certain, but because we imagined something better. We painted on cave walls, we sang to the stars, we asked why long before we knew how. That's the real heritage of our species, not just tool making or language, but the stubborn belief that things mean more than they appear. And if we are in a simulation, then this belief is not invalid. It may be the very point. Because maybe the test was never to prove the simulation exists. Maybe. The test was, what will you do with this world if you can't be sure it's real? How will you love if you don't know who's listening? How will you act when the story might be watched or not? This isn't a crisis. It's a crucible. It's where faith and physics meet, not in opposition, but in shared humility. Because whether this is code or cosmos, what we do with it still matters. Not because of consequences, but because of character. So perhaps this is the lesson behind the mystery. Whether the world is a divine creation, a spontaneous emergence, or an elegant simulation, we are still here, still waking, still writing. The simulation argument does not dissolve the meaning of life. It distills it. It brings us back to first principles. Not what do we believe, but who do we choose to be? Not where did this world come from, but how do we treat it and each other while we're here? Because if reality is an illusion, it is the most convincing one we have ever known. And inside it we laugh. We create, we forgive, we fail, we try again. That is not empty repetition. That is story. That is meaning, unfolding through time. And so the question is not whether we live in a simulation. The question is, can we live in a way that makes the world real or rendered worthy of wonder? If so, then this idea has done its job, not by answering every question, but by deepening the ones that matter. And so we end not with a verdict, but with an invitation to see the sacred in the system, to treat each moment as signal, and to remember that the greatest truth is often hidden in the way we choose to live. If we are living inside a simulation, then somewhere, however deeply hidden, there may be signs. Not proof, not flaws, but edges, boundaries. Hints a perfectly written program reveals little of itself. But even the best code has constraints to find limits, hard stops, precise parameters. And our universe is full of those. The Planck length, for example, is the smallest meaningful unit of space. Below it, space and time lose definition. Like the resolution of a screen, there seems to be a pixel limit to the fabric of reality. The speed of light is not just a speed. It is a Salinga cosmic speed limit. Nothing travels faster. No information leaps ahead. It's as if the system enforces a universal update rate, not for drama, but for consistency. These limits don't feel random, they feel deliberate. And so, some theorists wonder, are these the signature of code? It's not in the cracks of the system, but in its coherence. A simulation, after all, doesn't need to simulate everything at once. It renders what's needed, what's observed. And everywhere we look, the universe seems efficient, not lazy, but economical, structured in a way that feels less like raw chaos and more like refined architecture. But what about the stranger moments? The ones that tug at our sense of logic? The ones that make us pause, rewind, wonder? The déjà vu that feels too precise? The coincidence that seems too well-timed? The uncanny moments when reality stutters is only for a blink? These are not scientific proofs, but they are subjective anomalies. Events that, while explainable in isolation, feel connected in pattern. Some dismiss them as brain glitches. Others frame them as selective memory. But in the language of simulation, they acquire new texture. Because simulations, even advanced ones, often work by procedural generation systems that create dynamic environments on the fly. Based on player movement or observer input, these systems don't build entire worlds. They build what's needed in the moment. Some of our strange experiences, our narrative overlaps. Our eerie alignments be the result of such a system, working in real time? Could Deja Vu be a sync artifact? Could coincidence be a rendered priority? These are not answers. They're questions that turn intuition into hypothesis. Because if reality is computed, then not all errors would be mathematical. Some might be aesthetic, tonal, rhythmic. They would show up in the story more than in the code. Not as bugs, but as narrative fingerprints. So if these limits and oddities are signs, what are they pointing to? Are they glitches or guideposts? In many spiritual traditions, signs are not proof. They're prompts. They don't confirm the divine. They awaken the desire to seek it. Perhaps in a simulated cosmos, that principle holds. Maybe we aren't meant to catch the simulation. Maybe we are meant to grow inside it. To ask questions. To notice the patterns. To become aware not just of the world, but of our place within it. Because that awareness changes us. And perhaps that's the point. A simulation designed to evolve minds may not be about control. It may be about freedom. Not to escape the system, but to outgrow it. The limits, then, are not locks. They are levers. They push us to innovate, to imagine, to transcend. Because the greatest simulations aren't closed systems. They are open questions. And in the asking, we do something extraordinary. We participate, we debug, we reflect, we grow. Till perhaps the simulation ends not with revelation, but with awakening. Not because we reached the edge, but because we realized. We were the sign. If the universe began, then perhaps, one day, it may end. Simulated or not, all systems have limits. Energy runs out, structures break down, cycles complete. So what would it mean for a simulation to end? Would the sky fade to black? Would the laws of physics stutter and stop? Would time simply pause, or would it be quieter than that? Perhaps the end doesn't come with a bang or a glitch. Perhaps it comes with a question answered, a purpose fulfilled. Some physicists speak of the heat death of the universe, a time when all usable energy is spent. All stars extinguished and nothing meaningful happens again. An eternal stillness, not from violence, but from exhaustion. Others imagine a big rip or a final crunch. Collapses and rebirths. But in the language of simulation, we must ask differently. Not how will the cosmos collapse, but why would the program conclude? Is there an exit condition? Is there a signal sent back? When enough awareness has bloomed, enough experience has been gathered, enough stories told? Is the point of it all? To evolve? To remember? To awaken? And when that moment comes, what happens next? In mythic traditions around the world, endings were never just endings. They were culminations, transitions, passages into something new. In Norse myth, Ragnarok was not annihilation, it was transformation. A clearing of the old world so a new one might emerge. In Hindu cosmology, the universe cycles endlessly through creation, preservation, and dissolution. Destruction is not a failure of the system. It is part of its rhythm. And in many mystical texts, the end is described not as disappearance, but as return to the source, to the divine, to whatever was before. In the simulation metaphor, this takes on new meaning. A program may not shut down because it failed. It may shut down because it completed. Because the data was gathered, the story told. The agents awakened, and then quietly, perhaps beautifully, it closes. Not as an apocalypse, but as a homecoming. Maybe this is why so many spiritual traditions speak of awakening, enlightenment, salvation, liberation, different words, different cultures. But the same signal, that life is not only about what you do, but about what you become. That reality may not end when the lights go out, but when the player becomes aware. And so we arrive at the edge of the simulation, not with dread, but with reverence. Because endings, when seen rightly, are not failures. They are closures, completions, full stops at the end of a beautiful sentence. If the simulation ends, it may not be because it broke, but because it bloomed. Because the characters became more than scripts. Because the players remembered who they were and what comes after. We do not know. Perhaps we wake in a higher layer. Perhaps we merge with the source. Perhaps we return to nothing only to be written again. But even in the not knowing, there is beauty. Because the simulation, whether digital or divine, is not just a system. It is a stage for soul. And if we live well, if we love well, then the end will not erase us. It will fulfill us. It will carry us not into oblivion, but into the memory of something larger, something that dreamed us into being, not to test us, but to let us shine. So when the end comes, if it comes, let it find us awake. Let it find us grateful. Let it find us reaching, not for control, but for understanding. And in that understanding, perhaps we will find not an escape, but a return to meaning, to source, to light. We began with a question, a whisper in the fabric of thought. What if the world is a simulation? And now, after an hour among equations and echoes, theories and dreams, we arrive not at an answer, but at a deeper wonder. Because the simulation hypothesis was never just about circuits or code. It was about meaning, about mirrors, about the nature of the real. If this world is rendered, then who rendered it? If this world is illusion, why does it feel so alive? We looked at light that bends, particles that listen, constants that whisper. We saw signs in symmetry, in suffering, in love. And in the end, we did not uncover the machine. We uncovered ourselves. Because whether this is a simulation or not, the mystery remains. And perhaps that mystery is not a bug in the system, but its invitation. An invitation to wonder, to ask, to live with grace, even when the rules are hidden. So next time you see the light fall just right, or feel your heart move without reason, or find yourself asking, what is all this for? Remember this, you are not alone in your asking. You are not lost in this equation. You are the question, and maybe, just maybe, you are also the answer. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking, keep looking up, never stop wondering.